Good morning, ladies and gentlemen, dear colleagues. Thank you for accepting our invitation. Tibor, the Vice Rector of Eszterházy Károly Catholic University. Welcome to our conference on formal methods and foundation of AI. It's a great pleasure to see you here, to have you here with us. But how did we get here? Let me tell you a short story. It was about 5 years ago, during a coffee at the Lányka Bistro, or somewhere close to it, more precisely, somewhere on this hill, with Tibor and Tajti Tibor. We were discussing ways how to celebrate the Hungarian Academy of Sciences. And it was a hard and real brainstorming. And after a lot of coffee, Tibor pointed out that formal methods are a main research field for many of our colleagues. As he put it, this is almost a real mess. The point, this conversion led to start of our Hungarian language online workshop, Formal Methods in Computer Science in Hungary, formális módszerek az informatikában. Since then, we have organized 2 online and 1 hybrid event every year in November. The first workshop had 11, and the second workshop already had 30 speakers. Since the beginning, we have listened to more than 60 presentations in the field of formal methods. And the next workshop is coming this November, and we hope to see you there too. But in fact, this conference grew out of this workshop. But this time is more than that. This event became a real international conference. And we are very proud to bring together researchers from many countries. We believe that, combining formal methods and AI is a key to building safe, smart, and reliable systems. And now some technical information. Of course, the coffee breaks are the most important part of any conference, but in addition to the plenary and session presentations, I would like to highlight 2 special events. The first is the roundtable on AI on Friday after the plenary sessions. And the second is the Friday evening banquet in the Szépasszony Valley. Here, a world-famous singer-songwriter will be our guest, Péter Gerendás. As we call him, Gerendás Peti. We will hear many international hits from him, from Beatles' Let It Be to Gerendás Péter, Szép Júlia. Of course, we welcome everyone in love. In advance, I would like to thank Gábor Kusper and Gergely Kovásznai for organizing this conference. Gábor Kusper provides the heart and soul, while Gergely Kovásznai guarantees the high quality of this conference. And I would like to thank everyone else too, the local organizers and program committee members, and to all local forces. At last but not least, the conference sponsors, Mecenatura and KFI. Now, I wish you all an inspiring, educational, and collaborative 3 days for you. And now I would like to invite Tibor Juhász to give his welcome speech. The floor is yours.
Thank you very much, dear colleagues, ladies and gentlemen, dear guests. On behalf of Rector Ilona Pajtókné Tari and the management and the citizens of the Eszterházy Catholic University, I would like to give you a warm welcome to the first international conference on formal method and foundations of artificial intelligence. The number in the name of the conference, Csaba didn't say, the first suggests that this is not the last, and there will be a sequel. I'm already looking forward to the second one. Dear organizers, it's supposedly more difficult to start organizing the second one because you already know what is it about, including the difficulties and the challenges in the organizing. But if the second one succeeds, you can obtain the others by induction. I agree with Csaba in that this is actually not the first, because this conference is a continuation of the workshop established by him in 2020 in the midst of the pandemic. And this was a very, very excellent workshop put together in 1 or 2 weeks. And the fact that Gábor managed to find a source to cover the costs contributed greatly to the growth, so I thank him for that. It is also understandable that artificial intelligence has also appeared in the scope as it is one of the most exciting issues of our time. Some people face it with expectation and hopes, and some with fear. It is not yet known who will be right. Last week, one of the greatest bands in heavy metal, Iron Maiden, performed in Budapest. Raise your hand if you there were. If you were there. Nobody? Nobody else. Okay. This is a 50-year-old world-famous band who are also famous for not playing the tracks separately during the studio recordings, but together as if they were just at a rehearsal or concert. The drummer is responsible for the tempo of the songs, not a metronome. They don't leave it to a machine. They believe that this is the only way to ensure that the heart shows in the final result. I would also like to draw your attention to a message of His Holiness Pope Francis for the 58th World Day of Social Communications, entitled Artificial Intelligence and the Wisdom of the Heart Towards a Fully Human Communication. The main message of this text for me is that maybe sooner or later the machine will be as smart as human or even smarter, but there will be always a huge difference, and that is the heart. The machine will never have a heart. Dear friends, this is the main reason why I didn't ask ChatGPT to prepare this opening speech, because I have some sentences in my heart to tell you. Csaba, Gábor, Gergő, and the organizers, thank you Thank you very much. And thank you to all the participants for coming. And I wish you a very fruitful conference, beautiful presentations, and pleasant talking next to excellent wine in the evenings. Okay, and may your heart always be in the right place. Thank you for your attention.
Ladies and gentlemen, dear guests, my name is Olivér Hornyák. I'm associate professor at University of Miskolc. I will be one of the co-chair of this conference. I did ask ChatGPT what to tell as an opening speech, and I dropped the idea. I would like to add some personal. First of all, it's my greatest pleasure to be here. This is if you stop for a minute and look around where we are, this is a beautiful place. We are on a conference which is actually a big step up from the former workshop, and it's really good to be here. Also good to see the audience. I can see young faces, young researchers doing scientific jobs. So it's one of the greatest pleasure. But ChatGPT actually suggested to emphasize the importance of the topic, artificial intelligence. I think this is the only thing which I don't need to do, because everyone knows how important it is, how important it is for the education, how important it is because it will form our future in a way that we are not knowing when I'm doing this speech. I have been doing artificial intelligence researches for more than 25 years now, and I'm still learning new things every day. And I do hope that in this conference I will learn something new. So again, thank you very much for inviting me and to be here, and let's have a good conference.
Ladies and gentlemen, my name is Gábor Kusper. I am the chair of the organizing committee, and I think there is only one sentence to say, which is still left. I officially open FMF-AI 2022 conference. Welcome in Eger, enjoy, and I wish you fruitful conference. Thank you.
So I think this is the time to invite Professor Tibor Tajti to do his plenary presentation.
Ez nem akar működni, de felraktam a Google Drive-ra, hogy onnan is át tudom tölteni, hogyha... Megpróbálhatjuk, a másik oldalon is van. Csak nem tudom, hogy a géppel van-e a gond. Linux.
Deliver us a lecture from compute to analyze superintelligence, quantitative and formal perspective. The stage is yours.
That's it. Welcome everyone, dear chair, dear colleagues. We'd like to give you an insight from where we come and where we are going to from my viewpoint. Just a few words about the intelligence, because we are trying to produce intelligence algorithms, models, machines, robots. So intelligence, we measure the intelligence for the humans, but as we experience, the intelligence has many dimensions which are not measured by the single test. But somehow we measure the intelligence, and we also use values for it, for example, the IQ quotient, intelligence quotient, and from this diagram we see that by this measurement, not everyone is very clever. Okay, this is a very important point. It also has some cultural dependency, so not everywhere is the average IQ the same. So the presentation, this talk is about from the compute how we come to the intelligent large models. Just very shortly, we can see through the last few decades, we came from the 1 or few kilobyte machines to the many gigabytes machines. Not talking about the HPCs, which have already terabytes of RAM, for example. And the computing power also just from a few thousands of operations per second, now we have machines which can do millions of operations in a microsecond. So crazy is the speed of the development. A few decades ago, we did not talk about the AGI too much, but the first such milestone was meant to be the test whether the computer can ever reach the level of the human. When I was a student at the university, it was said that maybe never, but at least not soon. But after a few years, maybe 10 years, the chess engine won against the current chess champion human. And nowadays, the human versus machine championship is not interesting enough because the human has not, that doesn't have any chance. The human ALU points are between 2,800 and 2,900, and the chess engines, it was a development, of course, 24 years ago. It was a bit less than the human ALU point, and now this is a few years ago, but I also have a diagram about this improvement of the ALU points for the chess engines. Now the difference is very big. And many think, and personally I think that we are currently about this point where the machine reaches the capabilities of the humans. Regarding the chess, it was about 21 years ago, but now we are talking about the AGI, whether we can talk about the AGI now or next year or somewhere in the future. There are debates about that. Some tests show that this was 2 years ago that the first version of the GPT-4, which was not the first version of the ChatGPT. Sorry. When we got first the ChatGPT, it was version 3.5, I think, and the version 4 was the first really almost clever model, which was better in many tests than the human. These are school tests and similar tests. And here we can see the human result, average human, not the most clever human, but the average human result. And the GPT-4 was already better in many such tests. This is other such diagram about the progress that the human level is about here in the thinking and here in the listening, and the current best large language models are above the human level in some such tests. We will check some of these because as it is in the title of this talk, we can have an opinion, and probably these opinions can be different, but the numbers talk. So this is a quantitative perspective. This is, and many such diagrams will be about the improvements of the models. And I think this is very important because the question is not the most important is not whether we are above the human level now, or 1 month before, or 1 month after this date, but how how fast, how quick is the improvement, because if we can see, if we can agree that the machine intelligence is improving, then we can say that there will be a point. There are very, very different model sizes, and this will be also important for the next few minutes. The model sizes are important since more than 70 years, when Turing said that there will be a point in the future, in about 50 years, when the machine brain, machine memory will be large enough in terms of billions, then it will be possible that if human talks with machines and with humans, cannot decide which is which. And in 2011, it was already one such point. It was not yet AGI, or it may be a pre-AGI, and not yet the Turing test, but the machine running on a current HPC bet the human in a quiz called Jeopardy. And in the last few years, for example, almost 3 years ago, 2.5 years ago, it was said that ChatGPT already passed the Turing test. Okay, there are debates whether the control was good enough or not. And there were some articles about how it happened. Check the time. Oh, I think we don't have to check all of the contributors, but some of the contributors can be important for us, for Hungarians. The role of John Nyman is very important. We just mentioned Alan Turing, who was one of the fathers of the artificial intelligence, and maybe we can mention some of the current big AI people like Jan LeCun, or LeCun, I don't know how to spell his name, who works for Meta, I think, now as a lead. His name is very important because he just told or said just a few days ago that the large language models can be never AGI. But he works in the AI industry. Sergey Brin, for example, and Elon Musk, they say that we are very near to the AGI. It can come in 1 or 2 years. Andrew Ng also. Okay, when we are closing to the AGI, we can try to think about what will happen. Is there a risk? Is it scary to have something not human who will be at our level or even above our intelligence? And it is interesting to check this date when Asimov wrote the first novels about robots in 1942. He already sentenced the basic 3 laws of robotics. I will not read that. Probably all of you or many of you know that, and it is very interesting, I think. So now the current highest levels of machine intelligence when we are talking about the AGI direction, so not about specific AI tasks, but the general intelligence, and the current best such AIs are used in the GPT method, so they generate the response based on the input and previous path of the response. This is used for, this was used first for text, but nowadays such models are generating video, audio, and images as well, of course. Probably we can go through this very quickly because of this audience is aware of what happens in these models we are talking about. We try to model the human brain and intelligence based on the human neuron and connections. We model it in the computer programs. For example, the multi-layer perceptron was an earlier such model which was capable to do many things like image processing and so on. But then it was found that for some tasks, the multi-layer perceptron is not very optimal, and then there were invented some good models like the convolutional neural networks, which was invented by the aforementioned LeCun, Jan LeCun, and here it is said that, or it was measured that we can save many operations mainly for the vision, and such similar new inventions for the residual networks or the transformer models, which are used in the large language models, and the mixture of experts, which are multiple smaller models combined by voting, so as they are used as ensembles, so that we have many, maybe 8, but even maybe 20 some expert sub-models, and then some of them will be used for one input to give the response together. And then, for example, the linear attention. We will not go into this deeply, but we are talking about the transformer model architecture. Here is a simplified diagram of it. Basically, this is a very deep neural network. We are talking about, at the beginning in the, 2019, where the first GPT model was spread in the world, the GPT-2. It was not very clever, but was interesting already. It had maybe 7 layers or so, but nowadays I use 20 layers, such large language models, but I saw already 80 or even 100 layer models. And of course, I don't know how deep can be the OpenAI or the Google Gemini or the Grok models. When we are talking about or interested in where and how the AI can reach the human level, the first such well-known results, which were really measured with real correct tests, in almost 1 year ago, 24 September. Oh, it was, sorry, I left this in Hungarian. It was measured with many tests, but 3 of them are very interesting because these are high-level knowledge tests, like the math competition. These are invitational. What happened? Invitational mathematics Olympiad problems. The previous model was very weak. It reached only 13% accuracy, but this time introduced new models, preview version already almost 57%, and its big brother, what we were not able to use that time yet, it achieved 83%, and there were similar very big improvements in the competition for programming competition on the code forces. Here also, the previous version, I think the 4.0 version was released in the spring of 2024, and this September version achieved very, very high accuracy. And also in the PhD level science questions, it was also compared with the expert human level, which is about 70%, and these newer models give much higher accuracy. Almost 30% less errors or fails. Yeah, as I said, the intelligence, even when we humans are talking about the intelligence, sometimes we differentiate what kind of intelligence, like literature or mathematics, so there are different areas. And also the AI models are measured with very different kinds of tests. Like what we mentioned before, the mathematics or programming, or PhD level scientific questions, biology, chemistry, physics, and other tests. We must understand that it is very hard to tell when the AI will be better, or when the AI will reach the human level, because we could ask back, in what? Maybe in programming it will reach us earlier, because programming is one of the areas where these models are very strongly trained. Of course, it is very important, because if it will be good enough in programming, then it can help to improve itself. And that's why, for example, the CEO of the Anthropic company said that within a few months, the AI will do about 90% of the programming, and within about 1 year, all of the programming will be done by the AI. That's why the programming is one of the most trained area for the AI. I found this beautiful diagram on the net. I don't know how accurate this is, but this was published in September last year, when it was said that the O1 model of the OpenAI reached the IQ of 120, which is about the university student level, as far as I know. The human average is the 100, the men's level is the 130, for example. 120 can be the average university student level. Okay, that was just an experiment with an earlier image generation model. Okay, beside the programming, of course, the AI is trained for many, many things. For example, the healthcare as well, and many, many things. Oh, yeah. This is also some comparison between models of different dates, and we can see that, for example, the newest, at that time, the newest 4.0 is how much better than the model 1 year before that. Again, something similar. We can see the huge improvement from the earlier models to the newer versions. Oh, this is a timeline diagram about that. Here we show 3 companies' AI models. The Claude is from the Anthropic company, the GPT is from the OpenAI, and the Gemini is from the Google DeepMind. And we can see, this is, unfortunately, this is 1 year old, but we can see the trend, how quickly they improve. Unfortunately, I could not find same or similar diagram, which is more up to date. But we can see the trend. Sorry, this is the same. We saw already. I think we already told about that one. I think we can skip that. And when we told about the different tests and the different kinds of intelligence the human can have, just for 1 minute, we can check some of these tests. There are really many, many, so we cannot check all of these tests, but here are just a few which usually happen to be shown on such comparison diagrams or tables. But of course, we don't know, probably not all of you can could tell which is these GSM 8K or another one. So here are just very short descriptions of such benchmarks to have a feeling about what they measure. So, for example, the MLU variance measure general knowledge across various domains. The GPQA evaluates the ability to generate questions from paragraphs, so extract questions from paragraphs. For example, here, many colleagues are using these large language models to generate text, generate text from text, from the course material. Yeah, because we, from semester to semester, we have to produce a new test, maybe in multiple versions. Then this is, of course, mathematical, and here the reasoning is one of the key points. This reasoning was weak at the beginning, but the new models are much, much better in the reasoning, and they are especially trained for reasoning. Probably many of you experience that when you talk with newer models, then they usually explain more deeply. Sometimes we don't like it, but sometimes it is useful. And this reasoning is not only for us, but for the quality. So, for example, maybe you know this tricky question, what we used to talk about, that still sometimes still the newest models fail to answer correctly. Which is the greater, 2.11 or 2.9? And many large language models fail to answer this correctly. And if they are forced to use reasoning, we will talk about this later a little bit more, what we call COT, this is a technique what they use. Then they don't answer with the final answer, but first think on the problem and usually give better result. Okay, I will not talk about all of them, but for example, this live code bench is also very important, which measures code generation and execution skills. Yeah, and maybe, yeah, this insertion following is also important, because sometimes the large language models are clever, but don't do the task what we ask. So the insertion following is also an important feature. So they created such a benchmark. We mentioned that at the beginning the large language models were used for answering questions, but nowadays we can use them to do real works, so that they are already available to use from the programming environments, the integrated development environments, and also on the user interfaces on the web for these large language models. Sometimes, not for all of them the same, but we can find interesting features. For example, I asked the model to generate an entity relationship model, and it not only generated the model syntax, but also it invoked the rendering, so it happened to show up in the user interface. Okay. Again, this was a few months ago that it was a comparison diagram between many models. What is interesting that two of these models, no, three of these models are open source, which are among the best, maybe not among the best 3 or 5, but among the best. These LeLlama and this other variant of the LeLlama, the NVIDIA fine-tuned the LeLlama model, and this Mistral Large is also an open source model. It can be good for researchers, for example, because they can run it on their machines, and they can fine-tune the models for their research area, for example. Okay, again, some comparison tests. Here we see 6 benchmark results, and here we have already 2 of the best Chinese models. It is also something that we can talk about, that China came up in the AI competition. Some of their models already were released almost 1 year ago, but they were not very good. But last winter, in December and in January, they released some models which were very good, comparable with the OpenAI models, and open source, so you can download them. And they said that they did it much cheaper than the OpenAI. And that's also one point when these models get to be smaller, cheaper, then probably their development will be faster, because there can be more companies, more universities who can work with them. And maybe we can be thankful for the Chinese to do them. And really, almost every night when I check the latest news about the AI, for example, I check articles on the archive. It happens that almost every day there is something very good. Almost every day. And I think it can be correlated with this big competition, and not only with the Chinese ones, but that we have so many possibilities. And the Chinese ones, I'm not paid by the Chinese government, but this is not an advertisement, but they did really very good job. So here, if you check it, their open source model. Maybe it was not published because it was a preview yet, but since then we have the final version of the O1, which is no, not one. Sorry, the R1, and it's not thinking version of is called the DeepSeek, not R1, but the DeepSeek. So. Then the final versions for the open source, so you can run it on your machine. And they achieve very, very high performance. In some tests, they even are better than the OpenAI. In such cases, we also always have to be know that there is very big difference between the thinking and the non-thinking versions. And sometimes the same model can be used in both methods. The thinking is much more expensive because, for example, if I ask which is the greater, 2.9 or 2.11, then the quick answer can be just very few words. But if I ask reasoning, then to get this very short response, first, it thinks a lot, maybe for minutes, which consumes energy and money. Okay. Then some last slides. The 5.4 from Microsoft. It was not the best model, and still it is not the best model, but I wanted to show this diagram because it shows that with the improvement of the model architectures and probably the training data set and training method, they achieved a very big improvement in the quality, so that the model size is not big. It's 14 or 15 billion parameters, which is not big, and they achieved very high performance, and it is important. On the code forces, the O3 model, which came just maybe 1 or 2 months ago, it achieves very, very high performance. If we compare it with the earlier versions, we can see the trend. Very beautiful. Also in the mathematics competitions and the PhD level questions. In IQ estimation, it was not IQ measurement, it was IQ estimation by the code forces results, so that we maybe it is not true or not real in the sense of a real IQ, but it's an estimation and it shows the quality improvement. I told you that some guys predict the AGI, the artificial general intelligence, within 1 or 2 years, and maybe I will show. Yeah, this one. This already contains some newer results. I wanted to show this just for a few seconds. That on the live bench, live code bench tasks, how well they improve. So from the 10 or 20%. We are now about 70 and 80%. It's, I don't have words for that. This is another one, and maybe another one with some forecast. These are the code versus ALE points. Yeah, and there is a new such benchmark called ARC, A-R-C. And here I also found some good new results. So here also we can see the improvement. This is an IQ. I think that's all. Okay. Thank you.
Thank you very much. It was a very, very interesting presentation. We have a short time to have questions if you have. Please.
So one aspect that we don't really talk about is our dependence on these models as external services. So maybe OpenAI gives us an interface which we can use, but even if you want to access it via an API, you would have to pay. Do you think it would be reasonable to have these open source models at the university level so that we shouldn't have that many dependencies on companies?
Thank you for the question, but I think that's not so important at one moment, because this technology is very new, the competition is big, they are getting cheaper and cheaper, or for the same price we get more and more, and we also can have better and better models on our computers. So I think we can take it easy and check what happens within a few months.
Thank you. May I suggest that if you have any further question, then we will have it on the coffee break. So let's have a coffee break now, and then come back in 30 minutes. before doing the presentation. So, please go to this place.
Aha, to si nechce svetliť.
And there will be another photo after the plenary sessions, but this will be outside. But first, we would try to do an inside photo. So please, everyone, just come. Present voice of data, AI-based acoustic analysis for clinical classification.
Okay, it's a little bit slower, but okay. Okay, so good morning, everybody. Once again, my name is Peter Drotár, and I'm coming from Technical University of Košice, that is like 150 kilometers north in Slovakia. At first, I would like to thank the organizers for invitation to this nice conference. And yeah, this is my first time in Eger, so I'm looking forward to it. Oh, does this work? Okay. The slides was changed here, but not on the. Ah, okay. Okay. Okay, so before I start with the actual topic, I would like to introduce our lab, that is Intelligent Information System Laboratory at Technical University in Košice. There are like 3 of us that are senior researchers, then some postdocs and PhD students. Good for us, we are still growing, so hopefully we'll have some new PhD students, etc. And yeah, for those that are interested in any of those topics, I think we are open to collaboration or to any form of collaboration. So basically there are two main research topics. One that basically is driven by me. It focuses on biomedical signal and image processing and on machine learning topics. And the second that focuses maybe more on AI and autonomous mobility, edge computing, and basically some communications or telecommunications related topics, such as metaverse of things or similar. Just briefly some peek behind the curtain on what we are working on currently. So we work on extending the field of view of echocardiography, that is ultrasound of heart, or to generate the 3D ultrasound from 2D ultrasound, biplane ultrasound, or in the area of tabular data, we are proposing some feature selection methods or the methods that can learn even in highly imbalanced scenarios. So this is more on machine learning topics, just to see what else we are doing beside the topic that I will talk about right now or today. And today I would like to discuss how can be voice used as a tool for non-invasive source of information with some clinical application. In general, we maybe do not realize that, but voice captures very rich information. It captures information about our neuromotor processing because we need to think when we speak, or we can produce the phonemes. And there is also some respiratory aspect, so there is wave of breath, and there are also cognitive and muscular aspects. So we need to somehow move muscles or train muscles to produce speech or vocal cords. So it contains a lot of information that can be utilized, and I would like to provide some use cases or how can we utilize that. And in this topic, this talk, I will focus on disease detection and biomarker identification. Of course, it can be extended to disease monitoring, to some rehabilitation and intervention. But to not make it too long, I will focus only on disease detection, and I will focus on specific use case of Parkinson's disease. Why it makes sense to use voice as a signal? It's non-invasive, so we don't need any complicated procedure to get voice. We actually just need some common microphone or computer or whatever. If it's microphone is very common, so it's inexpensive, so we don't need any expensive equipment or any laboratory tests. And as I already indicated, it reflects a lot of physiological processes that are going on in our body. So whether this is neuromuscular control or respiration or some cognitive function, all this is somehow reflected in voice. So there is strong opportunity for AI or machine learning utilization, because what is AI good at is can detect some subtle changes that are maybe not visible or not, as a human, we cannot perceive these small changes, but AI can do that for us. So this can enable very early diagnosis for some diseases or monitoring of progression of diseases. Now, why we should focus on Parkinson's disease? The main motivation is that Parkinson's disease is right after the Alzheimer's disease, second most common neurodegenerative disease. So it actually affects voice, movement. The people with Parkinson's, they have tremor of the fingers or hands. And there is also some changes in posture of how they stand. So there are many different aspects of Parkinson's disease. And one that we are focusing on is the voice. Because the voice is between the earliest signs or symptoms of the Parkinson's disease. The changes are really small, and sometimes we cannot perceive it if we are not trained to do so. But there are some changes in voice. Of course, this is not ideal because, as in many medical domains, the available data are quite scarce. So we have only small, quite heterogeneous data sets. So in comparison to other AI domains or generative AI, for example, like a colleague before me was talking about large language models. They have plenty of data, so they can train large models, but in the medical domains, specifically in the Parkinson's disease analysis from voice, the data sets are really small, like having maybe 100 of samples, that's already too much. As you know, the speaker or the voice is very specific for every speaker. So there is high inter-speaker variability. As we know, the voice of the women is quite different from voice of the men. And then the voice develops with age. So the voice, again, of older people is quite different from pupils in the school. So there are very, very strong variability in voice. And we are not even thinking about some diseases yet. So there is like really high interspeaker variability. That's not always ideal when we want to classify something. And beside voice or variability in voice itself, voice is strongly affected by environment. So when you speak in the room, there is reverberation, there are echoes, and there can be noise from outside. So this, again, affects the recorded noise. So we need to think about how to record or when to record voice. Of course, you don't want to be recording when the neighbor next door is drilling to the wall or something like that, but yeah. So considering all this, there is a strong domain shift between the training or between some clinical setting when we developed our model and then real practice if we are to employ the AI or the model in some clinical practice. So the acoustics and environment is completely different. So we need to think about that somehow. And yeah, at the second half of this talk, I will try to show what the option or one of the options to resolve this problem. Basically, my concept for today's talk is to show some pipeline of how can be voice processed from from data or from the collection to data to some final prediction that is may be usable in real world or close to real world. So let's start with the data. Because if there are some data scientists, you know that they used to say that trash in, trash out. So if you have very poor data at the input, you cannot expect miracles at the output. So when you are collecting data that you are going to train your model, and you don't have the luxury of the huge data sets, you really need to be careful what to collect and how to collect. I already mentioned that we need to be really careful about the environment. So we don't want to have any strong noises or some interference. And it is recommended to use mostly the standard, not standard, but commonly used tools, so we avoid some bugs or some errors in recording. For Parkinson's disease, there are commonly used tasks. These are like sustained vowels pronunciation, so something like A, E, etc. The advantage of this task is that they are basically language and accent independent. Of course, there is still some accent, but if you just pronounce a vowel, the accent is not so significant or not so substantial as in case of free speech or in case of reading on some text. There's also one specific task that is called DDK task. So it's like quick repetition of these syllables or pataka or some different combination. Historically, there are some data sets like PC Gita, this is Spanish or Colombian data set, Neurovos, UCI, and there is strong research in Czech Republic, in Brno and Prague. There are two research groups that has some data sets, but the availability of data sets is quite limited. Luckily, in last years, there are some new additions like Iceberg data sets or PDSTU. This, I think, one is Chinese and one is Finnish. Yeah. So first, let me discuss the traditional machine learning approach. For you who work with machine learning, you know that if you process some signals or maybe even images, there are two approaches. You can either use traditional approach, like do some manual feature extractions. You can propose some handcrafted features. And for that, you need domain knowledge. So you should at least know what you are looking for, or maybe have some idea how to extract some features. And there is second approach that is trending in recent years. So it's deep learning approach. In the second case, you actually don't need to do any feature engineering. You just fed everything into the neural network and you hope for the best. So yeah, and usually you get at least something. So yeah, it's not something bad. So let me first start with the feature extraction. I mean, feature extraction to extract some features from voice with the aim to diagnose the Parkinson's disease, it is a huge topic. There are hundreds of papers on that, and the authors always try to find some new features that can provide better results, or that can be somehow more robust to the environment, to the gender variations or age variations. And you know that we as engineers, we have many tools, so we have in our repertoire the different transformations like Fourier, wavelet transformations, decompositions, and all these tools that we are eager to use. So we usually take these tools that we know and we try to apply it on something. In this case, it is voice, and we hope that this result that we get will be meaningful or will help the prediction. So there are really tons of different features. I will go through just like 4 or maybe 5, the most typical ones or most typical groups of features. The first are the features describing the phonation, and there is one that is very well known, that is fundamental frequency of the voice. Then we have very typical jitter and shimmer. So this is variation in amplitude and in the time. And most of these features that I mentioned that were used historically in speech recognition systems. So like before the speech recognition was a topic, the people use these features to translate speech to the text. Then we have features describing the tongue movement. These are, again, features that are historically used even from automatic speech recognition systems. We have formants, like first formant, second, and third. These formants basically characterize the position of the tongue. So different formants are for positions in different directions. So first is for, I think that for horizontal position. The second is for vertical position, but I think that's not really important right now. Then there are features describing the speech quality, and these are quite interesting for the case of Parkinson's disease, because one of the symptoms of Parkinson's disease is hoarseness. So there is something like noise in the voice. So the voice of the people with Parkinson's disease is more noisy. It means that there are more zero crossings, and the ratio of the harmonic signal to noise is lower in the Parkinson's disease. Another well-known group of features are male-frequency septal coefficients and linear predictive coefficients. This again came from speech recognition, where they were very heavily used. Then, as I mentioned at the beginning, we as an engineer, we like to use different methodologies or different fancy techniques to extract the features. So there are many features that are based on wavelet decomposition, empirical mode decomposition. By the way, if you process some nonlinear and non-stationary signal, I really recommend to have a look at this empirical mode decomposition. It has some very nice properties. And voice is basically something nonlinear and maybe non-stationary. And if we want to go even further, We can use the features based on fractal dimension, the different entropies, etc., etc. So there's really a lot of space for research or to apply different signal processing techniques. So this, I guess that this is why people like to do it. And yeah, when I was preparing for this presentation, I found another paper proposing some glottal features. It's from a very prestigious journal on IEEE transactions, so audio, speech, and language processing. So these new features, they are still topics, so people still try to find something more robust and something that can boost the classifier performance. Of course, there is danger when we are adding more and more and more and more features. There is some danger that is called, this danger is called the curse of dimensionality. It's not related to this voodoo doll, but in machine learning, we need to be careful in scenarios when we have like too many features and only few samples. And this is typical for again, for the medical domain. We have only few samples, only few observations. And if we extract too many features, it basically generates the sparse data space that in turn worsens the generalization. So the classifier tends to fit to noise. There are some spurious correlations. And all this affects the predictions or the final classification of Parkinson's disease or in general. So in case when we have like much more features than is the number of samples, it is recommended to do the feature selection on some other dimensionality reduction. And even in the case when you just perform some statistical testing, is it always good to use some statistical correction or correction tests, such as Bonferroni testing? So we have first step, feature extraction. Once we have extracted the features, so we did our fancy stuff, we can move forward and use some classifier. What we usually do, we load the scikit-learn library or something similar, and we try different classifiers. But let me have a word on the classifiers. It's not directly related to the topic, but it's something that I observed in the last years. So when you are trying classifiers, I recommend to start with XGBoost if you are not doing it. So it's state-of-the-art classifier that provides good performance even with default setting, and it was shown that it outperforms most of the classifiers on most of the data. Of course, we can use XGBoost or some alternatives such as CatBoost, LightGBoost machine, and Random Forest and AdaBoost. These are all basically ensemble classifiers that are quite robust, since the main characteristics of ensemble is that they should be a little bit more robust than the single classifiers. In recent years, there is a huge boom of neural networks. So it is the same in the case of tabular data that we need to classify. So there are many new architectures. Maybe the ones that are the most famous are TabNet or Saint architecture, that are based on attention module or attention mechanism. But there are, like, in 1 or 2 years back, or even this year, there are several studies that aim to compare the performance of the ensembles or the boosting classifiers to the neural networks. And these are all in very good venues, such as the IEEE transactions or NeoRIPS conference. And they all came to the same conclusion. So gradient boosting tree ensembles still outperforms the deep learning methods on tabular data. So there is still space, or that we need to move forward. So yeah, maybe this is something for PhD students. If you want to do some research, there's still space where we need to catch up with neural networks to achieve the same performance as the traditional ensemble classifiers. And yeah, if we are talking about neural networks, in the last years, we cannot skip or omit the foundation models. And there are already foundation models for tabular data. So these models, such as TAP-PFN, these are models like pre-trained on the huge data. So you actually don't need to train the model again. So you just take it and use it for inference. And again, this is something that can be interesting for PhD students, such a very, very interesting topic for research. To conclude the part about the feature selection or feature engineering, 2 years ago we did a study when we tried to find what features are used in most of the studies, or whether there is some feature that we can say that, okay, use this feature and it will be, you will get good performance. But we weren't able to isolate such features, but at least we came to the conclusions that it is preferred to use the features that can be somehow interpreted or can be linked to some physiological processes, so the clinicians can interpret it. And even though we haven't found any specific feature, there is huge potential for detecting the Parkinson's disease from voice. Okay, so that was the traditional approach. In parallel with traditional approach, that there are being developed techniques based on deep learning. As I mentioned, it has advantage that we do not need any strong domain knowledge. We don't need to handcraft the features. We just use audio and convert it to, for example, to spectrogram, and fed it to some neural network. Since this is the image, so the preferred network is, of course, convolutional network, or it may be some transformer-based network. Here we do not need to use the spectrograms. There are some alternatives. Some of these alternatives may be even better for diagnosis of Parkinson's disease, such as chromogram, gamma tone spectrogram, and wavelength scalegram. But it's basically all still the same. We are transferring voice to some image. What we did in this area is that it was few years back, and maybe you are familiar with transfer learning. So in transfer learning, we have some source domain, and there is some target domain. And usually the gap between these domains is not too big, so we can somehow transfer the knowledge from the general natural images to the classification of the Parkinson's disease. But as can you see, the difference between the natural images and the spectrogram is quite significant, so they are semantically not very close to each other. What we did is that we proposed the multiple fine-tuning of the network. So we introduced something called mediator data set. So instead of going from or training the network with the source data and then target data, we used the data set that is somewhere in between, let's say. And we use for example, in this case, we use the data set of vowels. So there are many vowels like A, A, E. And first we train the network with this data set of vowels. And only after that, we train the top layers with the data sets that's focusing on classification of Parkinson's disease. And as you can see on this 2D visualization, before application of multiple fine-tuning, the extracted features are somehow merged together, so they are not clustered around the classes. But after the multiple fine-tuning, the two classes, the Parkinson's disease patients and the healthy patients, can be more easily separated, or at least there are some clusters or notions of clusters. Another positive aspect of the multiple fine-tuning is that we can use multiple mediator data set to fine-tune the network. So we got functional diversity, actually. So we got many or multiple different networks that can be, again, used to build a classifier or ensemble classifier. And yeah, it helps on this data set and some other data set. It helps a little bit. So again, it is at the cost of performance or the computational cost. So to train multiple neural networks is more expensive than the training only one network. But yeah, it's always some trade-off. Again, the trend in the last year is foundation models. So even in the processing of the voice or speech, we can use the foundation models such as wave-to-vec or whisper for classification or Parkinson's disease. And recently I saw the paper when authors use both actually wave-to-vec and whisper. And we can use it in the same way as any neural networks. So we can either use these foundation models as a feature extractor. So we extract the features and then fed these features to some shallow classifier such as XGBoost or SVM. Or we can fine-tune this network to classify the Parkinson's disease. Of course, in case of whisper, I think that we need just first half that makes the extraction of voice features. So yeah, but what I wanted to say is that we can use also the large foundation models or large multimodal models to classify the Parkinson's disease. And this is again something that researchers are just starting to do. So maybe it's again some idea for research or for further research. Prediction. Yeah, so once we set up our machine learning pipeline, we train the model or run some predictions, and we got very nice results. We did some experiments for 4 different data sets. So even in the case when we are using the convolutional neural network, and same for the traditional approach, we can still get quite nice results, over 85%. This is all very nice and good. But the problem starts when we move from one data set or from data set that the classifier was trained on to the new data set. So we move to unseen data set. And again, in this case, we did some experiments, and we can see that when we train the classifier, and it again doesn't matter whether this is convolutional network, whether this is deep learning or traditional approach, we train the classifier. Sorry, I pressed the wrong button. So it doesn't matter whether we train it on 3 different data sets or we go from like one data set to a different one. The drop in performance is tremendous, so it's substantial. We are going from very nice 90% accuracy to something like 57. That is a little bit better than a random guess. So, and this is something that it's not, I just made up this problem to have some fancy topic, but when we are going to employ these models, we need to think about how to deploy them in the environment where the model, when the model wasn't trained on. So how to deploy the model on the new data or on the data from the new environment. And luckily, the people needed to solve this before. So there is something called domain generalization and a bunch of related topics or domains. In domain generalization, in contrast to other approaches such as transfer learning or domain adaptation, in domain generalization, we do not have access to the test data. So we do not have access to the deployment environment. So we have only our trained data, and we need to somehow adapt or make the model as robust as possible to perform well on the test data. So when we want to formalize the problem of domain generalization, yeah, I won't bother you too much with that, but let's assume that we have some notion on domain. So we have some data and Y stands for labels. And the domain is basically built by this data, and we have several domains. So the goal of domain generalization is to learn prediction function that achieves minimal prediction error on unseen, or we can call it on test domain. So formally, we minimize the expected loss on test domain. So we are trying to basically minimize the error on the test domain. Of course, this is very useful for formal definition, but in reality, we do not have access to the test domain, so we are actually not minimizing the error on the test domain, but we need to take another approach. And there are many approaches to achieve that. What we are focusing on currently is domain generalization through data manipulation, and more specifically through the data augmentation. So what we are trying to do, or what is the equivalent formulation of the problem, so we are minimizing the expected loss on the, of course, on the original data, but also on manipulated data. So, and how we get these manipulated data? What we do, we apply the label preserving transformations. There are also some transformations that are not label preserving, but we focus on these transformations that preserve the label. So they do not change the voice of Parkinsonian patient to the healthy voice. And we selected just a bunch of transforms that can be applied on voice. So we apply this transformation on voice. Even though I'm showing the spectrogram, they are applied on voice, and then the spectrogram is generated. And we didn't think much about what transformation to select, to use. We actually rely on some policy to select the best combination of transformations. So imagine we have this group of transformations, and we need to find some policy that will combine these transformations in the way that it will improve the robustness or the generalization capabilities of the model. So if you like math, it can be described like something like that. The question is how, what is this policy? And there can be, again, many different approaches to that. What we are doing is we are not using Q-learning directly, but we call it like Q-learning inspired augmentation. So we group different transformations into different combinations. So we have like several groups, or we call it buckets. So we have buckets of transformation, and then we try to train and evaluate the model and rank the different buckets. So if the bucket performs well, or the combination of the transformation performs well, then we are good. We give it some score. If it performs not so good, it doesn't get any scoring. So, and how are the results so far? In some cases, we can get quite nice improvement, even more than 10%. So we are get from 65 to 79%. Or yeah, in the mixed scenario, can again get from 69 to 78%, which is not great. Well, not great, not terrible, I would say. So, but because we have like 78%, 67%, so this is not high accuracy. But when you realize that in some cases the improvement is like 12%, so it's 12% is in machine learning. It's huge leap forward. So this is something that we need to improve maybe even further, but at least we can show that there is potential in using this data manipulation for domain generalization. I don't know how much time do I have, but I don't see any signs, so I can continue, I guess. So the Parkinson's disease is only one use case that I selected, but there are many other diseases, mostly neurological, such as Alzheimer's disease, Huntington disease, or ALS, that somehow influence the voice, and so the voice can be used for the classification on diagnosis and monitoring of these diseases. Then we have some mental health illnesses, such as depression, PTSD, and this again influence the voice. So we can apply the same, basically, very similar pipeline even in this case. And of course, COVID-19, pneumonia, these all somehow affect respiration. So this is another group of diseases. And one that I want to mention particularly is hepatic encephalopathy. That is not neurodegenerative or neurological disorder. It is actually connected to the cirrhosis or to the liver failure. And we collected the data from patients from hepatic encephalopathy. And we again try to do these AI models or the AI modeling. And actually we are able to diagnose also the hepatic encephalopathy from voice. So we are about to submit the paper for publication. And I think that we should be first ones to at least to show that it is possible to diagnose the hepatic encephalopathy from voice. The good thing about that is that there is basically no test for hepatic encephalopathy that can objectively diagnose the disease. So this can be really helpful for diagnosis. Okay, so this maybe are some results, but I will skip those. Just short stop. I came across different startups, but I'm not affiliated with any of those. I met them on the conferences or whatever, that focus basically on voice processing and also for not only, but also for medical applications. So this is not anymore only theoretical work, but there are first application or maybe first business cases that I know with startups, with startups it's always risk whether they will succeed or not, but at least there is some movement forward. And yeah, this is more or less it. Before I finish, I would like to make a little small advertising about the summer school that we are organizing in Bratislava. It's under the patronage of Eur-AI, so there are people from all around Europe, from Oxford, Groningen, etc. So if you have 1 free week and want to learn something about the artificial intelligence or machine learning, please check the website. And yeah, as my thank for invitation, if you send me an email, I can offer you 10% discount for the registration fee. So thank you very much for your attention, and I hope that I'm in time. So thank you very much.
Thank you. We were absolutely within the time limit, so we have time for questions. Please.
You mentioned earlier in the presentation that the scarcity of the data set to train the model is very high. So how you handle in the model or the training of the model, how you handle this imbalancement of the data set that you use to train the model, because this is subsequently will affect the robustness of the model.
Yeah. The scarcity is usually the reason for scarcity is that we are trying to extract too many features. So we have like 1,000 or 2,000 features and maybe like 100 of samples. So, well, there's not many things that you can do actually, unfortunately. One thing that you can do is that you really carefully think about what features to include. So you do not extract thousands of features, but only 100 or maybe 50. But the risk in this case is that you omit some important features. So this is one thing. And what we are actually doing is that we apply feature selection techniques. So these feature selection can reduce the number of features even from 10,000 to a few hundred. So we usually employ the feature selection, but you really need to be careful with the model validation to use proper techniques and evaluate the model correctly. So this is what we do mostly.
Please, about the CNN. So if I understand correctly, you generate an image and you do use two-dimensional CNN experiments. And have you tried using one-dimensional CNNs, such as in wavelength? Maybe that could. I'm just curious.
I know. Yeah. Actually, we in our lab we didn't do that, but I think I saw that some studies that did that, and performance was I think it works. It works. This is one thing, but it's not so frequently used. So I think my guess is that it works, but it doesn't work so well. So it can be used definitely, as in case of ECG signals, etc. So it can be used, but maybe there are some limitations. I don't know the deal, but yeah, it's one of the possibilities.
Thank you. We have time for the one last question. So please.
I'll try to answer. So you already mentioned the data set issue in this biomedical fields. In most of the approaches with Parkinson and dysgraphia researches, already 50% of the data set was patients that had this disease. And you reach 60% in one of them, and 70+% in another one. Do you think you will get same level of accuracy if the number of patients data set would be less than your whole data set benchmark? So you had 50% of them was already positive with this. So do you think you will get the same level of accuracy with the lower amount of patients in your data set?
With the lower number of patients?
Yes. So 50% was already true in the like data set.
Yeah.
They had a Parkinson or they had a dysgraphia in two different researches.
Yeah. I think having less patient, I think 50 is not enough. So having even less patient, I don't think that it would be better. I don't know what will be the. I think that there will be negative impact on the prediction accuracy, but to measure it, we didn't try it because, yeah, as I said, 50 is small enough number. So removing some of the patients is not the good practice to remove some of the patients because you somehow manipulate the data. Basically, if you know that maybe this patient is the voice of this patient sounds like healthy person, it's not good practice to remove it because he has the Parkinson's disease, so you need to include him in your cohort. So yeah, I don't know the answer. I don't know how it will affect the performance, but I think that removing the patient will negatively affect the performance. Sorry.
Thank you again.
Thank you very much.
Google presentation, which is called Teaching Robotics, the AI Robot Project.
Yes, please. So hello everyone, and I would like first to thank you, Gábor Kusper, for the invitation. It's a great pleasure for me to be here today and to introduce you our AI Robot project. You already received this flyer with some of the information. So our project entitled Artificial Intelligence-Based Robotics is an European project, Erasmus+, cooperation partnership for higher education. And this is an ongoing project. We have three years to finalize. And the consortium consists in five universities from different countries. You can see here the key persons for each of the universities. So we have University of Macedonia, Thessaloniki, Greece, University Eszterházy, Károly Catholic University, Eger, Hungary, with the key person Gábor Kusper. And I would like to say that we are very lucky to have Gábor Kusper in our partnership, in our consortium, together with his team. He brings a very important contribution to our project, and we have a fruitful collaboration, and we managed to successfully complete another previous project, ARC, Automated Reasoning in the Class, 2019-2022. And the other partners are Aachen University of Germany, key person Eric Abraham, and University of Lorraine, Metz, France, Sorin Stratulat. So the target groups are both academic staff and students of all levels, bachelor, master, and PhD students. And academic staff, teachers which are teaching courses related to robotics, artificial intelligence, and formal verification, and also researchers in these three fields. And the main motivation of the project is that higher education in computer science needs to permanently adapt to the rapid technological changes. So robots are playing a very important role in modern society. They bring significant benefits in various fields like manufacturing, medicine, scientific research, education, home assistance, and so on. And they represent a constant source of innovation and research. And robots can benefit from artificial intelligence algorithms to make autonomous decisions and to adapt to new situations. And the third topic is formal verification, where we have to formally verify, formally prove certain properties such that we ensure the correctness of hardware or software systems. And this is very important because robots which interact with humans need to satisfy certain safety requirements in order to assure the fact that they do not cause any danger to humans in their interaction to humans. So in order to assure the correct functioning of such safety critical systems, their automatic synthesis and analysis is of high importance. So the aim of the project is to increase the quality and the attractivity of the related departments at the partner universities by a significant raise of the level of competencies and skills of the relevant academic staff in the fields of artificial intelligence, robotics, and formal verification, and also to address the European priority in national context, namely inclusion in higher education, namely social inclusion, improving the outreach to people with fewer opportunities, including people with disabilities, people with migrant background. So what is the main focus of the project? So this is an innovative project which focuses both on research and on teacher training in these three fields. And within the project, we will develop a comprehensive set of didactic support materials. We will have the AI Robo Kit together with scientific publications and at international conferences. And the kit will contain the AI Robo Book, 7 robotic applications in different fields, together with tools and video tutorials. So these materials, when they will be ready, they will be uploaded on the website of our project, and they will be freely available together with the implementation code for the robotic applications. And all these materials will be used as a support in teaching courses at the partner universities, and we hope that also other universities around the world will use our results. So I will start with the trainings as outcomes. So until now, we managed to organize 4 trainings. The first training in robotics, which was held by our partner Eszterházy Károly Catholic University. The second training in robotics was held in Greece, University Macedonia from Thessaloniki. Then the third training was related to the verification of robotic hybrid systems. And the fourth one was related to robotic algorithm synthesis and certification, which was held at the West University of Timișoara in Romania, and also included trainings related to PBL, problem-based learning. This is a modern student-centered approach in teaching. The AI Robo Book and the tools. So the AI Robo Book will be structured in 5 chapters. The first one will be an introduction to robotics. The second, programming and simulation of robots. The third, artificial intelligence for robotics. The fourth one, related to the verification of robotic algorithms. And the fifth one will be dedicated to describe complex robotic applications. And this book will also include practical conclusions from the robotic applications that we will develop, and will include also links and the video tutorials, and as well as the code, the implementation code for the robotic applications. So the chapter 1, which is dedicated to the introduction to robotics, will provide the historical context and foundational knowledge. And will include technical topics like robot manipulation, locomotion, things related to sensors, to control, actuators, servomotors, and kinematics. And includes also hands-on Arduino projects using the sensors, motors, as well as 3D printing. Chapter 2 will speak about programming and simulation of robots, and covers robot programming from low-level control to high-level behavior, because this is the quote of the book, from zero to expert. And here we will include simulation and digital twins for testing and optimization. We will introduce ROS for simulated and real-world robotics. We will present QVAT for image annotation and training data set, and we will also include tutorials on navigation, perception, and vision-based tasks. Chapter 3 is artificial intelligence for robotics. Here we will introduce basic concepts, machine learning, computer vision, reinforcement learning, information regarding the neural networks, data-driven decisions, and we will show AI integration for perception, planning, motion, and autonomy. And we will include examples of AI-enhanced robotics in real-world tasks. We will use Unity for the simulation, and we will highlight the ethical concepts. Chapter 4 is dedicated to the verification of robotic algorithms. So at the beginning, we will start with hybrid systems and automata for modeling discrete continuous robotic behavior. And also explores the verification techniques, reachability analysis, flow pipes, clustering, aggregation. And then we will introduce two systems, the Cox system and the Theorema system, in order to certify some robotic algorithms. And the focus is more on the certification of the sorting algorithms, which we will use in one robotic application. And of course, here in this chapter, we developed some scripts in Coq and some tools in the Theorema system for algorithm verification. And all these that we developed will be included in the book. And we will compare the two systems from the point of view of usability, automation, educational value, and we will also discuss complex and performance in real time for robotic systems. The final chapter, chapter 5, describes complex robotic applications. So we will cover 7 domains where robotics impact society and industry. And we will have one robotic application for assistive robotics for disabilities, for people with disabilities and special education needs. Robots that socialize with humans and help orient themselves within our institutions. Agricultural robotics, cobots in industry, illustrating the human-robot collaboration. Then healthcare robotics. Here the plan is to use neuroscience headsets in order to interpret the signs of the people which suffered an AVC. Telepresence robots for remote interaction and mobility support. Soft robotics, and we will see if we will include other extra robotic applications, because we found out that there are other domains which can be included here, like developing games together with the robots, and also robots as home assistants. The tools and the video tutorials consist in the developed tools for chapters 4 and chapter 5, the ones which I already mentioned in the Theorema system and in the Cox system, in order to show the verification and the certification of robotic algorithms. And the video tutorials contain the simulation of the robots for all the other chapters, so including the videos showing the robotic applications which we are going to develop. So the robotic applications, AI-based robotic applications, these will be designed from academic, agricultural, industrial, and medical domains, with the aim to be used both in research and in teaching. In research, to evaluate algorithms, and in teaching, AI-based robotic courses, as well as a very good support as practical applications for theoretical courses, which students find very difficult to grasp, and most of the time they do not understand why do they need to learn so theoretical or so abstract subjects. And this is the main point, to have practical applications for the theoretical courses as well, such that we can have materials for teaching, which will be very exciting for the students, and will make students to be more motivated. 3 of the robotic applications will be designed as a support for people with disabilities and special education needs, and also for vulnerable groups like refugees or seniors. And for developing this robotic application, we will consider these phases. So we have design and simulation, testing and verification, and practical experiments. And these phases are based on multiple theoretical topics which are covered in our partner institutions. Some of these are graph theory, search algorithms, heuristic functions, motion planning, pathfinding, analysis, formal verification, automated theorem proving, and more and more. So regarding the robotic applications, we first started with the formally verification of some algorithms, because this is we found this the most challenging thing, how to combine the formal verification with robotics. And why it is important. So algorithm certification or program verification have an increasing importance in the current technological landscape due to the sharp increase in the complexity of software, and which cause adverse effects in case of failure. And for instance, robots constitute a particular class of systems that can represent high risk of software failures. And sorting has a growing area of applications, and sorting is essential for data processing in domains like climate, monitoring, robotics. And formal verification ensures the correctness and safety in dynamic and multi-robot environments. So what we managed to do, we managed to verify several sorting algorithms operating on natural numbers using the two systems, Theorema and Coq. And we can use natural numbers to represent real-world attributes like weight, size, color, and so on. Just a few information regarding the two systems. So Theorema system is a software system developed at the Research Institute for Symbolic Computation in Linz, Austria, and is implemented based on Mathematica, and the proving process uses only the rewrite mechanism from Mathematica. This is a very nice system with a very friendly user interface, and offers support for mathematical theory exploration, for proving in natural style. This means that the proofs are generated similar to human proving. They are very easy to read and understand. We can define and also execute the algorithm, and this system is very flexible, so we are able to construct provers for several domains. Yeah, so if you want to develop this system, it's very friendly, so to say. The Coq system, it's a skeptical theorem prover based on Curry-Howard isomorphism, where proofs are terms and properties are types. And this is also a nice system which offers support for mathematical theory exploration, defining and execution of the algorithms, proving properties about the algorithms, and the certifications of proof scripts which are certified by the kernel. So how does it look? One property which we can verify for the sorting algorithms in these both systems, I have put here the logical conjecture for the Theorema system. So what do we need to prove in order to verify one sorting algorithm that is correct? So given the sorting algorithm sort, we have to prove that the output is sorted, and then that the algorithm preserves the multisets. Yeah? And in this manner, we developed several methods which are used for the domain of natural numbers and for lists. And these tools in Teorema and the scripts in Coq will be integrated into our intelligent robotic arm application, where we have a simulation of an industrial robot which sorts some objects. And of course, these tools will be included in the book. So some of the publications which we obtained for, which we had for last year for the formal verification of sorting algorithms. So certification of tail recursive bubble sort in Teorema and Coq at the LPAR conference, which was held in Mauritius, Africa. Certification of sorting algorithms using Teorema and Coq in SCSS, which was held in Tokyo, Japan, and certification of insert sort and merge sort in Coq in this IEEE conference. So how do we connect this formal verification with collaborative robots in industry? This is work in progress for the simulation of the industrial robot. We have a simulation in Coppelia Sim. So we have here the vision sensor. We used here a robotic arm, Franca robotic arm, together with the Barrett hand for gripping. And this is the plane with the boxes, and this one behind the robot is the plane for the final placement of the boxes. So through the camera, the robot will detect the coordinates of the boxes and will rank them. Depending on how close they are to the robot. So #1 is the closest, #2 is further, and so on. And establishes the center of the box and then targets the box for selection, and then it will move the box, so gripping, lifting, transport, and then place the box in the right place. So this is what we are working now to integrate the formally verified sorting algorithms in this robot, and we will try to analyze and to test how different sorting algorithms behave in different contexts. Another robotic application which we are working on is for indoor navigation using robots. So the specification is that the robots will interact with people from vulnerable groups with migrant background, language, foreign persons, refugees, elderly, and will help orient themselves in our partner institutions. And the first attempt was to use the Pepper robot. We have a Pepper robot, and we wanted to use Pepper to explore the environment and to create by herself the map. And we did this for a very small part of our university, because it took, for 15 minutes, it took like 4 hours and something, yeah, to scan the environment and so on. So I can show you what we did at the beginning. Oh, there is no sound. How can I increase the volume? Ah, okay. Maybe not. Yes. Okay. From the.
Do you want me to come with you? Hello, my name is Pepper. How may I assist you?
I want to go to the room 036.
To get to the room 036, you need to go straight forward. It is the second door on the right.
Could you please assist me?
Do you want me to come with you?
Yes.
Okay, please follow me to the room 036.
By herself, avoiding the obstacles. And when
here is the room, please go inside, the teacher is waiting for you.
Okay. And when we figured out that Pepper cannot cannot scan the environment because the university is big, then we thought how to scan the environment, what are the methods to scan the environment, and one idea was to use the another robot, Scout Mini, which has LiDAR, and it can scan in a few minutes the entire ground floor of the university. Yeah, and why do we use Pepper robots? So Pepper robot is developed by Aldebaran Robotics and is an excellent social robot that can be used for indoor interaction with people and to assist people. But making Pepper autonomous is a bit challenged due to the hardware and the software limitations. And some key aspects to take into consideration are how to guide the users from one room to another one inside the building, how to avoid obstacles which can be fixed or mobile obstacles like human which occur on the way, how to develop and understand the environment, so the map of the building in order to find the way, and how to scan the environment to create the maps, 2D maps and 3D maps of the building. And finally, we decided to use another robot, Scout Mini, for the ground floor mapping of our university. Actually, we used 2 Scout Minis because we wanted to experiment what is the difference between 2D maps and 3D maps. So we have one Scout Mini with 2D LiDAR and one Scout Mini with 3D LiDAR. So our applications reduced to the problem of generating the detailed 2D and 3D maps for our universities using collaborative robots. And these 2 are the robots which are involved, so the Scout Mini and the Pepper robot. And we used some reference points. Namely, we used some 3D objects from a children's game called Shape Sorter, and actually this was Gabor's idea. And we use this for the robot to easily recognize the environment. And the goal, of course, was to enable Pepper to interactively assist individuals by utilizing the 2D and 3D maps which were generated with the other robot. And this is a photo illustrating Pepper in the hallway and the 3D objects which we used as reference for scanning the environment. So as methodology for generating the maps and how to integrate this into Pepper. So for the Scout Mini, for the data processing and visualization, so data is segmented based on the movement of the robot. And the point clouds are processed using the open 3D library. And of course, during the scanning, there was a lot of noise because we have windows, we have doors, glass doors, yeah, and the sensor goes in. And we had to somehow reduce the noise, so we applied the DBScan algorithm in order to reduce the noise, and then we segmented point clouds which were visualized and saved. And now the thing is, we are working on importing these maps into the Pepper robot. And the steps are to convert these generated maps to a format which is accepted by Pepper, and then Pepper to utilize these maps for navigation and to provide information to the people based on their queries. So the publications which our results were published in these two publications. So we had generating 3D maps with collaborative robots in proceeding of the IEEE conference ICE CCME, and also a case study in building 2D maps with robots in proceedings of ICINCO. Another nice application is the telepresence robot. So the specification is to have a robot which will find a path, will avoid obstacles, and will act as a telepresence robot. So if you are traveling and you want to participate to a meeting at the university, the thing is to have a mobile application from where you can remotely control the telepresence robot, send him or her to the room where is the meeting, and when the robot reaches the room, enters the room, and you create a Google Meet meeting, and you can see everything which is inside the room, and you can speak through the robot tablet, and you can see what is inside through the video camera which is integrated in the robot. So the components which we used, so before continuing, I want to tell you that for each application we have several versions. We started with one version. We figured out that this one can be improved. Maybe the robot is too small, or maybe it has some troubles when navigating. And this is somehow version 2 of the robot. And we figured out that being so big, like 1.2 meter, we can also use this telepresence robot for the other application, which will help, which will interact with people and will help them orient themselves within our institutions. So the components, we have ESP32, a Raspberry Pi, stepper motors, motor drivers, PCB prototype board, video camera, tablet, 2 speakers, and a lot of 3D printed components which were necessary to assemble the robot. So the robot here is the video showing that he is autonomous navigating. And here, so this guy creates on the mobile phone via the application, creates a new schedule meeting. And now in this moment the meet was created and appears on the tablet of the robot, and via the video camera he can he can see the surroundings. And also the meeting which was scheduled, which was created, will appear on the calendar on the mobile phone. Yeah. Another application is for illustrating the soft robotics. So 3D soft globe for interpreting the signs of deaf-mute people. The specification is to have a soft robotic device which is printed on the 3D printers. That will include actuators and sensors and will be used for interpreting and translating the signs language of deaf-mute people. So the components here, again, we had several versions of the glove. First of all, we started with the 3D design in order to have the skeleton of the glove. And at the beginning, we wanted to use Raspberry Pi and a lot of driver motors, but it was too heavy on the hand, so it was very heavy to carry. And to wear it like for 2 minutes, it was very heavy. So now we have a simpler version which has sensors and uses only an ESP32 with display. And we have different sizes, one for adult hand and one for children. So this is the status. So the blue skeleton is from soft material, printed using the 3D printers, and we have sensors, and depending on the moves on the ESP32 display shows the coordinates, and in this moment we are collecting data such that we can figure it out what are exactly the signs, and we also have to, so for the interpretation of the sign language of deaf mute people, this is not so easy because I found out, I didn't know, I found out that for each language they have, for each country they have a different language. So for example, for Romanian is different, for Greeks is different, yeah, and in this moment we have the device and now we are gathering data, and the next step is to conduct some studies regarding the language and how can we interpret in different languages. Okay, the last robotic application, which actually was not included in the project proposal, but for me it was interesting because I read some very interesting papers regarding the serious games developments, and for me this was very motivating to have a robotic device which plays a game, yeah, and to use this robotic system for students such that they can also play with the robot, but they can also analyze the code which is behind, and each component separately, individually, they can debug separately, and they can also have hardware working and software, so something which is a real world application also for theoretical courses. Sorry, and for the motivation, most of the existing serious games are purely digital. Physical systems add embodied interaction for greater engagement and understanding. And the game tic-tac-toe is a classical problem in artificial intelligence education. And it is mostly used to illustrate the concept of minimax search algorithm and decision trees. And most existing robotic implementation rely on deterministic AI strategies and offer separate gameplay logic from hardware interaction, and in this way they limit their educational value. So we developed a robotic system, a robotic arm which plays the tic-tac-toe against a human player. And we submitted a paper entitled Robotic Tic-Tac-Toe System as a Multidisciplinary Educational Tool to the International Conference on Games. So the system overview is novel, is low cost, which combines robotics, computer vision, and AI for a physical tic-tac-toe game. It uses a cheap robotic arm with simplified stamper mechanism for reliability and for reducing the costs. And it has a modular design, computer vision with OpenCV, planning in C++, and robot control with Arduino, and the game states logged via CSV JSON. And this is an interactive learning experience because we have a hands-on environment for exploring game AI, real-time decision making, and interactive gameplay. And also, as I said, enables students to explore, to debug, and extend the individual components. So as educational outcomes, we use the, so instead of Minimax, we use the A-star algorithm, and this system also aligns with the trends in robotic education, namely computational thinking and adversarial thinking. And as future work, we plan to integrate machine learning frameworks for robust board detection. We plan to extend the tic-tac-toe grid, and also we plan to conduct some studies for classroom impact evaluation. So let me show you a bit how this is working. So here is the robotic arm, the camera, the player, the human player places the X, which is with black, and now the robotic arm makes the move. And after the player places the piece, it's pressing the button capture, and in that moment it's AI turn. After the robot makes a move, the player has to press the button OK. And now, after capturing, one more move, and shows that the AI wins. And also, it has a database containing the scores. How many times the player won, and how many times the AI won, and when it was a draw, of course. Very important, my very last slide is that at the end of the project, we will organize two big events. One is the International Summer School, which will be held in June, July 2026 at the University of Macedonia in Greece. And the goal of the summer school is that students to be familiar with our results, with the AI RoboBook and the robotic applications, and to solve practical exercises based on problem-based learning principles. The selection of the students will be made based on their application. So we will open the system, I think, in January, February next year. So anyone who is interested can submit the application, and then the committee will select 20 applications. So we have four travel grants for each partner, we have 4 travel grants, yeah, for 4 students. So in total, we have 20 travel grants available for this summer school, but also if you have students which are outside the partnership and are interested to participate, they can apply, and we will see how we can provide support. Also, at the very end of the project, in the last month of the project in November 2026, we will have the International Conference on AI Robo, which is worldwide open to academics and researchers and people from industry which are interested in our subjects. And here we have a limited number of travel grants which will be awarded based on the submission. So if you are interested to participate, I invite you to submit the application. The call for application will be open January, February next year. And the main objective here is not for the participants to give a talk to the conference, but to participate, to be familiar with the results of the project, especially with the AI Robo Kit, the book, the tools, and the robotic applications. So finally, thank you for your attention, and I invite you to subscribe on our website if you want to be to receive messages every time when we upload the implementation code for one robotic application or the content of the book. And also, we will inform you when the call for applications is open, both for summer school and for the international conference. And if you like to follow us on Facebook or on LinkedIn, here are the QR codes. Thank you so much for your attention.
Thank you very much. We have some time for questions.
Yes.
Thank you for your presentation. It was so amazing. I am interested in STEM education. Just I have a question about this kit. Is available globally or locally?
Yes, this one will be available for anyone in the world who would like to download the material, the book, the robotic applications, and also the robotic applications will include not only the implementation code, but also a documentation, like a tutorial, step-by-step, how to develop from scratch the robotic application. And so everything, all what we develop will be available on the website of the project. But you have to, when you press the button download, you have to insert your email and institution so that we know that our material is used. Okay.
Thank you. Another question?
Yes, please.
Yes, please.
So you mentioned that there is, according to the application, characteristics should be adjusted. And in future, so it's going to be like the version, according to the application, is varying and changing. So for example, any future plan for version that focusing on soft skills. For example, once I've been involved in a project to use a robotic assistant in elderly house, a retirement house, and one of the most important focus was the soft skill, how to handle elderly. It's delicate process. So in this way, do you have any future plan to focus on this, or like to have the robots to be enabled, or like have more skills about those soft skills?
Specifically for the elderly people, or
kind of like this kind of application, yes. Because you mentioned like it's as assistant building to show some directions and like playing a games could be in that direction, or like.
Yes, so in total we plan to have 7 robotic applications, and actually for the elderly people I will show you another application after lunch. We have one more presentation. We have one joint paper with Gabor and with the partners from Greece. And so first of all, what what are the steps to develop the robotic application? First of all, we try to identify what we need, yeah, and we build one robotic application. But if we identify that, I don't know, maybe like, let me take the example with the glove, yeah, if it's too heavy and it's not useful, then no, we have to change it. We have to simplify the device and we have to adapt it and so on. And also for you said something about focusing on software development.
No, soft skills, like
soft skills. How to interact.
Example, are they sad, angry? Are they accepting the existence of the robot? Or are they taking their medication? They're refusing maybe. Something weird for them, like especially for elderly, to accept this kind of technology. Because now we have really, there was some issue to address that the shortness of the caregiving staff, and this were like really unnecessary, like something from the from need they needed to develop such a robot. But this some ethical obstacle and something really important vital point to focus on, like how to improve and how to address this issue, like the soft skills.
Yeah, thank you very much. This is a very important thing. We will address these ethical aspects in the book. But regarding the applications, in the previous plan, so to say, this was not planned because we, the design for, the proposal was to use the robotic applications only for teaching and to assist people with disabilities within our universities. But this is very important, and we can take this into consideration, yes. So, especially if we direct the applications to other kind of people, to elderly people and so on. Yes, this. Thank you so much. This is a very good idea for the next project.
Thank you for your
Thank you.
Two pieces of information. The photo session is postponed to tomorrow, so we won't have a photo session right now. And we will have a dinner in the building since start. You need to go downstairs and you can go inside the building or outside the building and enjoy your dinner. And I hope that all of you will come back after the dinner to that session.
Just one more piece of information. Pepper is waiting for you. Pepper is a humanoid robot. Pepper would like to say some greetings. So please visit. I don't know, please or not.